In this tutorial, we will look at how to determine the ionic equation for a given reaction. In the first example, we will look at the reaction between lead-2 nitrate and ammonium sulfate solutions. The first step is to write the balanced symbol equation for this reaction. Lead-2 nitrate and ammonium sulfate react to form lead sulfate and 2 ammonium nitrates. You also need to include state symbols in your equation. Lead nitrate, ammonium sulfate and ammonium nitrate are all in solution, so have the state symbol AQ to show they are aqueous. Lead sulfate, however, is insoluble in water, and so has the state symbol S to signify it is a solid. The second step is to write out compounds which are in the aqueous state in terms of their constituent ions. Therefore, lead nitrate is written as Pb2+ and 2NO3- ions. Ammonium sulfate is written as 2NH4+ and 1SO4 2- ion, and ammonium nitrate is written as 2NH4+ and 2NO3- ions. This is because there are 2 ammonium nitrates in the balanced equation. As lead sulfate is a solid, it is kept as PbSO4. The third step is to find the spectator ions. These are ions which are found in the same state on both sides of the equation. When we look at our equation from step 2, we find that we have 2 NO3- ions and 2 NH4+ ions on both the reactant and product sides of our equation. These are our spectator ions and have been shown in purple in this equation. The fourth and final step is to write the ionic equation for the reaction. This is done by rewriting the equation from steps 2 and 3, but this time removing the spectator ions from the equation. By highlighting the spectator ions in step 3, this should be easy to do. Our final ionic equation for this reaction is therefore Pb2+ Aq plus SO4 2- Aq goes to PbSO4 solid. Now for an example to try yourself. Silver 1 carbonate is reacted with nitric acid. Give the ionic equation for this reaction. Pause the video now and work this out. The first step obtains the balanced symbol equation, including state symbols. Solid silver carbonate and nitric acid react to form aqueous silver nitrate, carbon dioxide gas, and water. The second step rewrites the 2 aqueous nitric acids as 2H+ and 2NO3- ions, whilst the 2 aqueous silver nitrates are written as 2Ag+ and 2NO3-. As the silver carbonate, carbon dioxide and water are not aqueous, their formulae are left as is. The third step identifies the spectator ions. In this example, only the 2 NO3- ions are found on the left and right hand sides of the equation in the same state. The last step is to write out the ionic equation for the reaction. This is the same equation as for steps 2 and 3, this time omitting the 2 NO3- Aq ions from both sides of the equation, as they were found to be the spectator ions in the previous step. This gives a final equation of Ag2CO3S plus 2H plus Aq goes to 2Ag plus Aq plus CO2G plus H2O L.